Hi, hello, namaskaram. Welcome to Vidya Setu. We welcome you all to our new batch, Vridhhi, the complete tech portion batch for AAI ATC. Today we are going to learn functions. My name is Abhishek, and let's go us into like our functions chapter. Okay? Yeah. So introduction. What is basically a function? Does anyone know? See, this batch is completely dedicated for ATC exam, and I will teach you that which is necessary for ATC and that which will make you to crack ATC. Okay, if you want to learn mathematics, that doesn't mean that it's a bad thing, but now it's time to prepare for ATC. So let's focus on ATC. So what is function? Function is just relationship between the inputs. What is relation between inputs? For example, let's say there is a there is a there is a box like this. Okay, and here there is some output like this, and some water or some liquid is flowing into this. Okay, if I pour some liquid into this, it will go like this, and some of the liquid will go like this also. So if I give something, what I am getting outside, like input here, output here, this is a function. The whole mechanism happening here is a function. In simple words, okay, something I'm giving here, and something is happening here, something is happening here. And let's take, we want this output, so we consider this as input and this as output. The mechanism or the function happening here is function. Okay, I hope you understood. So what is a function actually? Function is relationship between two sets where each element in the domain is associated with exactly one element in the range. What is a set? What is domain? What is range? I'll explain you in a simple words. See, for example, if we have 1, 2, 7, 9, 8, 4, this is simply a set. Okay, and we can call this as domain also, because see, if I take this tub, I can put all these values into this is domain. Okay, I get only 9 and 8 can be come out like this, so this is range. Simple words. Okay, what is set now? Set of few values, prescribed values. What is domain now? What is domain? For which the function exists, for the values that function exists. What is range now? The output values. See, function is a relation between two sets where each element in the domain, that means let's say this is set A, this is domain. Okay, domain, set of input values is associated with exactly one element in the range. This is B, and this we call domain, codomain. Okay, let's say we have A, B, C. We have 1, 2, 3. If each element in the domain, if each element in the domain is associated with exactly one element of the codomain, that is called a function. If each element of the domain will have this kind of relation, means this is not a function, that is just a relation. They are having just relation between two sets. So you understood, right? What is a function actually? Each element in the domain, this is domain, okay, this is domain, having exactly one element associated with the value of domain in the codomain, and these values with which the set of domain values associated is called range. I will explain about range and codomain and domain in the next slide. This much you understood, I hope. So a function is always denoted like this, from A to B. F is function, set A, set B, that is domain and codomain. This is domain, this is codomain. This is the relation. This is the relation between A to B. That means A is mapping towards B. Okay. Yeah. A is set of domain values. B is codomain. Set of possible output. Okay. This is a set of input. Set A, but set B is possible output. It may be or it may not be. And F is a function that maps each element from A to B. Remember, function means exactly one element only should be mapped for the domain values. There should not be more than one value. If there is more than one value in the whole set, in this whole set, if there is more than one value, then that is not a function. I'm stressing so much here because this is very important. Okay. Only one element should be associated with one element of domain. Okay. You got my point. If one element of A is having more than one element associated in B, then that is just a relation, not a function. Okay. Function notation, yeah, you already know, we knew it as f of x, where f is a function and x is the input value. Okay, input value. And if I take just f of x is equal to 5x plus 2 or 3, then I can put whatever values I need here, real numbers, whole numbers, integers, whatever. But output will be also whatever real numbers, whole numbers, integers. Okay, that means f of x is a function where for any value of x, the corresponding output will be this one. That means I'll give an example. F of x equal to, let's take 2x plus 3 only. I'll give f of 1. That means in place of x, put 1. Okay, sorry, 2 of 1 plus 3. This is equal to 5. See, for 1, let's say this is S set, this is A set B. Okay, for 1, we are getting 5. If we put 2, what will we get? 7. This is a function. We may not know, but just I'm telling only one mapping, right? So this is a function. Okay. Next slide. Now I'll explain you clearly what is domain, what is codomain, what is range, because this is very important. That is why stressing here. The further topics, right? They are like just cakewalk. If you know function, domain, codomain, range, then the further topics are very easy. Okay. Sorry. What is domain? Set up all possible input values. Whatever you want to give, whatever you want to give as input is domain. Okay. The possible outputs, these are only possible outputs, not exact outputs. Okay. Codomain is just a possible output values. The set of values that the function may map to. We do not know whether it maps to that value or not. But codomain is a value or the set of values the function may map to. Okay. Now range is the actual output, the very much actual output. So what is the difference between actual output and the function may map to? I'll tell. See, I'll take this example later, but now you just listen to me. See, very simple. Let's take f of x is equal to x square plus 2x. Okay. What all the values can I put into this? Any value, right? I can put 1 by 2, I can put 0.5, I can put 3, I can put 5, I can put minus 7, whatever, right? So let me take integers as input value. This I am defining. Okay. So what are the possible outputs? This is input. What are the possible outputs we may get? Possible outputs. Those also might be positive, negative, whatever, right? So possible output also may be positive, negatives, zero also sometimes. So it will be integers. But exactly what happens here is in integers, let's take minus 1. If we put minus 1 here, it will be minus 1 plus 2 minus 1. Sorry, minus 1 whole square. This will be 1 minus 2 is equal to minus 1. If I take 0, f of 0 is equal to 0 square plus 2 of 0 is equal to 0 plus 1. F of 1 is equal to 1 plus 2 of 1 square is equal to 3. You see, minus 1, 0, 3. The in between values we have, 1, 2. If I put more values, we may miss other values also. So these are there in codomain. These are there in codomain, but only these are the range. You understood? The values exactly for which the function maps itself is called is called range. The values for which exactly the function maps itself is called range. But domain can be here, 1, 2 also can be there, right? That is the difference. You understood what is the difference between domain, codomain, range? And always range will be subset of codomain. Okay, it may be equal also. So range will be always subset or equal to codomain. Again, I'll repeat for you because I want you to concretize this concept. Domain means the possible input values that you can put for which the function exists. Codomain means the possible outputs that function may map to. But range is the actual output that the function maps to. Okay. Now, let's take an example. They have given for the function f of x equal to x square. X square. A equal to our set of real numbers. Maybe this set A means domain, I think. Okay. Domain, and let's say this belongs to equal to also same belongs here. The codomain also is also R. They have given codomain, that is B also, as B belongs to R. Real numbers. Okay, R means set of real numbers, R is set of real numbers. So they have given codomain and domain as R. But what are the output values we'll get for x square? If I put -2, what is the value? 4. If I put -3, what is the value? 9. If I put -10, what is the value? 100. That means where I can explain you this. Yeah, let's take the small part here and I will explain you here. Okay. See, for f of x is equal to x square, they have given a belongs to R, means domain belongs to R. Domain belongs to R. Okay. R means minus infinity to plus infinity. So you put f of -11 whole square. What is the value? 121. This is positive. If I put f of 10, this is positive value, and for positive we'll get 100. That means range is equal to 0 to belongs to 0, 0 to infinity, right? Not negative values. This is what domain, codomain, and range. They already defined what is domain in the question, what is codomain in the question. Okay, but the range is different. Range is 0 to infinity. Okay, 0 to infinity. I hope you understood this concept. I made it very clear for you because this is very important. Okay, let's go to next slide. Type of functions, and this is also very important. Yeah, I'll define them and I'll explain you how to find what is 1 1, how to find what is 1 1, what is onto, what is bijective. Okay, there are three types of functions. One is 1 1, another is onto, and last one is bijective. That means the function is both 1 1 and onto. Sir, what is 1 1 function? A function is said to be 1 1 if different values of A mapping to different values of B. That means the mapping values of one element in A should not be mapping to the same element. That means what is 1 1? Okay, I'll tell you with example. Don't worry, I'm there for you. Huh? See, this is set A, this is set B. First of all, to be a function A, B, C, 1, 2, 3. To call this relation as a function, each element of A should be mapped to at least one element of B. That is what we read, right? Okay, see here. A function is a relation between two sets where each element in the domain is associated with exactly one element. Okay, this is a function. Yeah, we know that. So what is 1 1? 1 to 1 function is different elements in A mapped to different elements in B. That means if the element in A mapping to this two and B also mapping to this two, then is this 1 1? No. If it is mapping like this, one element of A, set A maps to only one element of set B. That means different elements. A is different, B is different, C is different. And A is mapping to 1, B is mapping to 2, 2 is different from 1, C is mapping to 3, 3 is different from 2 and 1. So this is 1 1. Okay. Sir, now what is 1 2? Sorry, on 2. Let's see. Set A as P, Q, R. Okay. Set B domain and codomain. This is domain, this is codomain. Now I'll take minus 9, minus 12, minus 6. Whichever you want, you can take. This should be a function. For function, what is the condition? Each element of A should be mapped to some element of B. I'll again show you the definition because it is very important. Okay. Each element, see, each element of the domain is associated with exactly one element of the B. Okay. So this is a function now. P is associated with this, R is associated with this, Q is associated with this. Okay. Now is this 1 1? Yes, sir, it is 1 1. But what is onto? Onto means if every element of codomain has some pre-image in the domain. What does it mean? That means every element. See, for example, this 12 is not mapped to anything of A. See, in A we have PQR, in B minus 9, minus 12, minus 6. But this 12 is not mapped to anything. This is nothing. So this is not onto. Is this 1 1? Is this 1 1? Yes, exactly. It is 1 1 because different elements of A map to different elements of B. And is it a function now? Is it a function? Each element of A should be mapped to B, right? Each element of A mapped to B. Tell me, is each element of A mapped to B? No, then that is not a function. So a function should be there. A function should be there, and that every element in the B should be mapped with at least one element in the A. Sir, you can ask, you are telling at least one. That means can it be mapped to other also? Like this, minus 6 mapped to Q and minus 6 mapped to P also. Yes, it can be. It can be. But is it 1 1? No. I'll give you other example. Then you'll understand very clearly. See, you understood what is 1 1, right? Each element of A is associated with only one element and different element. Okay, one element means that is a function. Different elements. Element of A is associated with different elements of B. Same element should not be there of B. Okay. So here 1, 2, 3, 4, 5. A, set A. This is set B. This is P, Q, X, Y, Z. What is onto? I'll tell you very simply. Okay. Onto means if every element in the codomain has pre-image in the domain A. That means every element in the B, every element in the B has a pre-image. That means that is onto function. You see now every element P, Q, X, Y, Z. These are associated with at least one element, right? At least one means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, infinity. At least means one should be at least available. So at least one value is associated with P, at least one value associated with Q, at least one value associated with X, at least one value associated with Y, at least one value associated with Z. But these values are not mapped. That doesn't matter for us. You just look at the definition. Function A to B is onto if every element in the codomain has a pre-image in the domain. Every element in the codomain, you just remember every element in the codomain mapped to or having a pre-image in the domain A. That is, for every B belongs to B, there exists at least one X belongs to A such that f of X equal to B. That means f of 1 is equal to, we have P, comma, Q. Can you tell me, is this a function? Yes. Yes. Can you tell me, is this 1 1 function? No. So you understood what is 1 1, what is onto. So what is bijective now? When both 1 1 and onto, this is a function. Yes, this is a function. This is a function. You understood, right? Is this 1 1? Yes. 1 2 1 means different elements of A associated with different elements of B. Yes, different association is there. Onto means every element of B should have a pre-image, at least one pre-image in A. Then we have in this B having at least one pre-image in A. That means this is 1 1 and on 2. That means it is bijective. If you practice few problems, you'll understand. I will make you to practice. Don't worry. Okay. Okay. Now there are few functions, yeah, which you should be aware of. There are different functions like constant function, identity function, polynomial function, rational function, modulus function, signum function, greater than zero function. I have given you these things because they will directly ask questions on this. These things I have given you, right? You may get directly this value in the exam paper. What is signum function? They will ask like this: f of x is equal to x for x get greater than 0, like this, and they'll give this option in one option. Then you may call like mark it as correct. So these things are very important. I'll explain you what is constant function, what is identity function, what is polynomial, what is rational, what is modulus, what is signum, what is greatest integer function. Okay, chalo. First, what is constant function? Okay, what is constant function? Very simple. We do not function as f of x equal to something, right? But if there is a variable, then the function will be varying. But if there is a constant, it is a constant function. Whatever you put, 1, 2, 100, 26, 52, 33, whatever you put into this 1, 2, 100, 33, 26, 52, the value is c only. Only c. I'll give an example. F of x is equal to 5. Whatever I put here, a is domain, a belongs to our real numbers. I'll put -1. What is the value? 5. I will put 0. What is the value? 5. What is value of when I put 1? It is 5. That means whatever the input value may be, the output value will not change. That is constant function. F of x is equal to c. This is a constant function. Example, f of x equal to -3. Whatever you put, you'll get -3 only. Okay. A constant function. What is a constant function? Of the form f of x equal to c, where c is constant. It gives same output for all the inputs. Very simple, right? Very simple. Then what is identity function? What is identity function? See, now identity function. Okay. Identity function is a function which maps to itself. For example, if I say f of x equal to x, is x varying now? Yes. And what you're getting? The same varying path, varying value. If I put f of x place 1 in the place of x1, what is the value? Replace x with 1. If I put 2, what is value of 2, right? If I put -10, what is the value? -10. If I put -9, what is the value? -9. This is identity function. 1 is mapping to 1, 2 is mapping to 2, 3 is mapping to 3, -1 is mapping to -10, -9 is mapping to -9. This is domain, this is codomain, and mapping is happening towards itself, right? It may be two sets, A and B, but the value is same, right? Towards itself. So we call this as identity function. What is identity function? Identity function is a function in the form of f of x equal to x, where it maps to the same input value that is given there. F of 1 is equal to 1 only. F of 3 is equal to 3 only. This is identity function. Okay. Now, what is polynomial function? You know polynomials. A x power n, a n minus 1, x power n minus 1. That means the power of x reduces, right? A function in the form of f of x equal to, I'll keep the heading. Okay. Polynomial function. Okay. F of x is equal to x a power n, maybe plus or minus. Sign doesn't matter. Sorry, I'm putting an xn plus an minus 1 xn minus 1. This is x. Okay. Like this it goes constant c last. A function in this form, that means the exponent power of x will be decreasing. Okay, power of x will be decreasing, that is a polynomial function which is in the form of an x power n, an minus x power n minus 1. Okay, example x square plus 3x plus 2, you know this one. What is a rational function? This is also very easy. Rational number, like if you can just express that function in p of x by q of x form, that means a by b. What is rational number which can be expressed in p by q form? The same way, p of x by q of x. Okay, these two polynomial rational functions are not more important, so I'm not giving much explanation on that. Now modulus, signum and greater integer function are very important. I'll give you about that. Okay, what is modulus function now? I hope you can hear my voice properly. Okay, let me confine properly small things because we can have to complete all these things. Do we have other slide? Yeah. Okay, what is modulus function? Modulus function is a function in the form of f of x is equal to mod x. We denote like this, and it gives absolute value. It gives absolute value. So what is absolute value? So let's say there is minus 2. What is the value of this is 2. What is the absolute value of this is 2. Let's say minus 100. What is the absolute value of this is 100. What is the absolute value of minus 99? It is 99. So if you take a modulus function, it always returns the absolute value of the number that you have put in the function. This is a number that we put. This is the absolute value that we get. And we can define f of x as f of x is equal to x if x greater than 0 minus x less than 0. Greater than or equal to 0 we can take. Okay, so what is this? F of x in place of x you put 1. What is there? X greater than 0, right? X greater than 0, right? 1 is greater than 0, right? Or equal to 0. So what I have to use? X, right? X. So in place of x, 1. It gives absolute value. F of minus 9. Minus 9 is less than 0, right? X less than 0. So for minus 9, what is the, like, x less than 0, what is the output of the function of modulus function? F of x equal to minus x, right? Sorry, minus x. So put the value of x here, minus of minus 9. See, value of x is minus 9. Absolute value is 9. Okay, this is modulus function. Understood? It gives always absolute value, not positive value. Okay, positive, yeah, positive. Yeah, whatever you tell, this is positive. Okay, this is negative. Because we are defining it at greater than 0, less than 0. Little deeper, okay? Actually, it is absolute value of the number. Okay, so that is a function where output is absolute value of the input, that is modulus function. Done. And if you take the graph of this, I'll explain 3 graphs like after explaining the concepts. Okay, what is signum function now? A function, signum function, sorry, signum function, a function which always returns minus 1, 0, 1. What this exactly means is it returns the sign of the value. Okay, for example, if I tell f of x is equal to, signum function definition I'm writing here. Okay, I'll give example later. It returns minus 1, 0, 1. Returns minus 1 when x less than 0, 0 when x equal to 0, plus 1 when x greater than 0. So what does it mean? If I take f of x equal to minus 12, this is a signum function. Okay, then what is the value of signum function now? Like if I put this value minus 1, okay, minus 1, f of 12, 1, f of 0, 0. Okay, see, depending on the sign of x, we define f of x equal to minus 1 for x less than 0, f of x equal to 0, 0, f of greater than 0, f of x equal to 1. Okay, this graph I'll tell you here. You understood, right? It always returns just 0 or 1, 1, or -1. This is -1. This is +1. This is 0. This is a graph. Okay. This is x-axis. This is y-axis. Always it returns +1 for positive, -1 for negative, and 0 for 0. This is just sign function. It will just return the sign. Okay. Next, what is greater integer function? Okay, this is little you must understand. Greater integer function. Okay, we denote it as like this. Sometimes they might give gif of x square bracket. Okay, it always returns, greater integer function always returns the lesser value of the input value, absolute lesser value of the input value. So what does this mean? Absolute lesser value. Let's say f of x is equal to, this is greater integer function. I have taken f of 0.3. The value which is absolute and less than this. What is this? 0.3. Okay, the value which is less than 0.3 and absolute. What is that? 0. Right? For example, f of -1.2. The value which is absolute and lesser than this value. What is that? It is -2. Okay, it is -2. F of 3.7. Lesser than 3.7 and which is absolute, that is 3. You understood? If the graph is like this is 0, +1, +2, -1, -2. These are like -1 is greater than -2, -2 is greater than -3, right? And 1 is less than 2, 2 is greater than 1, 3 is greater than 2, 2 is less than 3, right? So if I take 0.9, 0.5, let's say, then greater integer function gives 0. If I take 1.7 or 1.8, it will give 1. If I can take 2.3, from 2.0, sorry, 2.00000001, what it will give? 2 only. I can take 2.9999999 infinity nines. What it will give? 2 only. You understood? This is greater integer function. I'll give graph also here. You understood, right? Hope you understood. Absolutely understand it. There is no question of not understanding it. It is a step function. We call it step also. For 0, it will give 0. Okay. For like 0 point something 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 something, it will give only 0. That is, this is a value. For 1 point something 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 something, it will give only 1. Okay. Only 2. Okay. Only 3. Okay. This is -1. Okay. -2. Okay. This is 1. This is 2. This is 3. This is -1. This is -2. Okay, this is the step function. It always returns the output value as the absolute value which is lesser than the given input value. What is greater integer function? A function where the output is greatest integer less than or equal to the input value. Understood? Understood. I'll give the modulus function graph here. Modulus function graph is like f of x equal to mod x always returns the absolute value, like positive value, right? If I give 1, 1. If I give 2, 2. Okay, 2. This point, this point. If I give -1, only 1. If I give -2, only 2. That means this is the graph. Okay, this is modulus function, signum function. You understood this one, greater integer function, this one. Hope you understood. These are the basic things and important things for more important things for your ATC exam. Okay. Now composition of functions. This is important. This is very simple and very important. Okay. What is composition? The basic word composition means mixing of something, making something, the composition, right? So the same thing, the composition of something is denoted as f of g. If you have some other function h, if you have some other function a, some other, so we will not use this. Some other function p, some other function q. This is all composition. So let's take confined to two function composition, f and g. It denotes by f of f circle g is equal to f of g. This is composition. Okay. Okay. Sorry, I'll write it for you. F of g is equal to f of g. Okay. So what exactly happens here is, with example you'll understand. Let's say f of x equal to 3x square and g of x is equal to 5x. We want, let's say 5x plus 1. We want to find f of g. Composition of f circle g is equal to f of g. Yes or no? Right? Or f of g of x. Okay. So in place of x, what you have to write here? In place of x, what we have to write? G of x. Just write f of, in place of x, we have to write g of x, and g of x is 5x plus 1. And in place of x, we got 5x plus 1. And what is f of x? 3x square. So in place of x, 5x plus 1 whole square. 325x square plus 1 plus 10x. 75x square plus 30x plus 3. Understood? If you have not understood, I'll go with one example, reverse way. Okay. F of x is equal to 2x. G of x is equal to x plus 1. The given example. But I'll take g of f. Now g of f of x is equal to, in the place of x, what we have to write? F of x. What is f of x? 2x. In the place of x in function g, what is there? 2x. So in the place of x, what we have to replace? 2x plus 1. This much you understood, right? This much you understood, right? In the place of just replacing the value of x with the other function, just replacing the values. Okay, done. I hope this is very easy for you. There is no need of stressing on this. Yeah, next go to next slide. Inverse of the function. Inverse is very simple, like composition. Just we have to inverse it. The inverse of a function is denoted as f inverse. Okay, is denoted as f inverse, and it reverses the mapping of f. What exactly they are telling is, let's say A is mapped to B. That means, sorry, A, B, 1, 2, 5, A, 6, C. Let's say there is a function f of x. It is something, we are putting 1 here, it is mapping to 2. We are putting 5 here, it is mapping to A. 6 we are putting here, it is mapping to C. So the mapping reverses. What happens is, if we put 2 here, it will map to 1. If I put A here, it will map to 5. If I put C here, it will map to 6. That's it. Just the mapping is reversing, getting reversed. Okay, mapping is getting reversed. Let's say f of x is equal to 2x. Real numbers is the domain. 1 is equal to 2, f of 2 is equal to 4, f of 5 is equal to 10. Now you write a function such that f of 2 is equal to, or should be 1, f of 4 should be is equal to 2, f of 10 should be is equal to 5. You understood? I have defined a function f of x equal to of x, and given that domain A belongs to real numbers. So for some values I have found something as mapping values. For f of 1 we'll get 2, f of 2 4, f of 5 10. So we have to define a function like this, f of x equal to something, so that if I put f of x place 2, f of 2, then I should get 1. This one exactly. If I put f of 4, then I should get 2 exactly. If I put f of 10, I should get 5 exactly. Okay, that is inverse. And to function to be inverse, it should be bijective, both 1 1 and onto. What is 1 1? Every element of A should be mapped with only one element of B. What is onto? Every element of B should have at least one pre-image in A, that is onto. Then if these both conditions are satisfied, then it is bijective. Only if it becomes bijective, then it is inverse function. Done? Done. Let's take an example of f of x equal to 2x plus 3. And yeah, we will solve for f inverse. How to solve for f inverse? Just make it equal to y. and write in terms of y. That means put all the values other side except x. 2x equal to y minus 3, x equal to y minus 3 by 2. Okay, done. Now just replace, interchange x and y. Just interchange x and y. Y is equal to just variables x and y, x minus 3 by 2. Okay, what is y now? These two are anyways equal, right? What is y now? F of f inverse x. Okay, x minus 3 by 2, not f of x. This is inverse function. Okay, just simple. Denote this f of x like this. This x is equal to f inverse of y. Okay, I told you you have to be getting the values right. So if I put f of 1 is equal to 2 of 1 plus 3, this is 5. So in inverse this function, if I put 1, I should get 1, right? If I put 5, I should get 1, right? This is f of x, so I got 5. In f inverse f, if I put 5, I should get 1, right? Because I have given 1 here. 1 is mapping to 5. Here 5 should be mapping to 1. So put the value as 5. F inverse of 5 is equal to 5 minus 3 by 2 is equal to 2 by 2 is equal to 1. Yes or no? Is it proved or not? That's it. Inverse means the mapping gets reverses. That's it. This is inverse function. Okay. The properties of function. This is also important. Direct questions will be coming on this. What is even function? Even function is very simple. Let's say f of x is equal to some 3x plus 2. If I put f of minus x, I'm giving an example. Don't take it so seriously. Okay. If I get 3x plus 2 here, then these became equal. These two became equal, right? Because the values are same. So this is even function. If if it becomes like this, I'm just giving an example. Minus of f of x, this is odd function. This is very outlined example, but I'll give you proper example to you understand. Okay. So what is even function? A function is even if f of minus x equal to f of x, where x is domain. Its graph is symmetric about y-axis. I'll tell you why it is symmetric about y-axis. A function is odd function if f of x is equal to minus f of x. And for all x is in the domain, its graph is symmetric about origin. I'll tell you what is symmetric about origin. Okay? Yeah. This is last topic. It's very easy. Functions is very easy if you become like perfect with whatever concepts I'm explaining you here. If you learn these things now, definitely you'll solve function problem. Sets and relations I'll explain you. Don't worry. Okay? Done. What is even function? With example, I'll tell you. Even function. I told you, right? Even function means f of minus x should be equal to f of x. So let's take an example. F of x is equal to x square plus 2. Now let's find whether it's even function or odd function. F of minus x. So replace x with minus x in the variable function or the polynomial function. What is minus x whole square? X square plus 1. Is this value and this value same or not? That means f of x is equal to f of minus x or not. That means defined or not, is even function or not. That's it. That's it. If you want other example, I will give all example. Just be with me, okay? F of x is equal to x square plus 3x. Now f of minus x is equal to minus x whole square plus minus x. Okay. Now what is happening here? F of minus x is equal to x square minus 3x. Is it same like this? No. Is it like this at least? No. That means it is neither even nor odd. I'll come to this example later also. Just be with this. Okay. Now what is odd function? Odd function. Okay. What is odd function? If f of minus x is equal to minus f of x, then that is odd function. I'll give an example. Let's take with example you'll understand. X plus 2x, okay, or x cube plus 2x. f of minus x is equal to minus x whole cube plus 2 minus x is equal to minus x cube minus 2x is equal to minus x cube plus 2x. See this value, like just put that minus aside. This value and this value is same or not? Same. That means f of minus x is equal to minus f of x or not. This minus outside, this minus inside a bracket, okay? Same or not, these two functions. That means this is odd function. You understood? I'll tell you what is symmetry about y-axis and origin for odd function, okay? Let's take this is x, this is y. I have given example x square plus 2, right? For 1 we'll get 3. This is x value. This is x square plus 2 value, okay? For 2 we'll get, I will take 0. For 0 we'll get 2. For minus 1 we'll get how much? Tell me how much? 3 only, okay? For 2 we'll get 6. For minus 2 we'll get how much? 6 only, okay? Let's take this is 0, this is 1, this is 2, this is minus 1, this is minus 2, this is 1, 2, 3, 4, 5 and 6, okay? So if I put value x0, what is the value of x square plus 2? That is 2, okay? This is 2. This is a point 0 comma 2. If I put value as 1, what is the value? 3. That means this is the value, this is a coordinate, right? If I value as 2, what is 6? Okay, if I put value as minus 1, what is the value? What is the value? 3 only. If I put value minus 3, minus 2, what is the value? 6 only. And the graph become like this or not? It is symmetric about y-axis or not? That's it. Very clear, right? Done. What is about origin? We just put some values. This is x value, this is x cube plus 2x value, okay? This is minus 1. For minus 1, what you'll get? Minus 3. 0, what you'll get? 0. 1, what you'll get? 3. Okay, just put that value 0, 1, 2, 3, minus 1, minus 2, minus 3, 1, 2, 3, minus 1, minus 2, minus 3. For 0, what you got? 0 only. For 1, what you got? For 1, you got 3. Okay. For minus 1, what you got? For minus 1, x minus 1, you got y as minus 3 here. Okay. Minus 1, y as minus 3. This is a value, right? See, this is for 1, this is 3. See, about the origin, it is symmetric. If you take more values, now you will understand. You might think, sir, this and this one and this one are symmetry about y-axis. No, y-axis means it should be like, see, you understand this mirror image. Symmetry means mirror image. This is not mirror image. It is like symmetry about origin. Origin, okay. This is symmetry about origin. Then these are the concepts of functions. You should be very familiar for ATC. And now we'll solve few examples. Okay. Yeah. Find the domain of the function. I'll write f of x is equal to 1 by root x minus 2. This function domain we have to find. What is domain now? For all the values, the function should be existed, right? I'll solve this answer. Yeah, here I will find. Okay, first answer. If you don't understand this, look at it, try on yourself. If you not doesn't get it, we have given solutions at the back. You can just go to the back slide. Okay, we have to find domain of this function. Okay, domain we have to find. So to make this function to be like valued, not valued exactly, make this function to make it valid. Okay, what should happen? The denominator should not be 0. That means x minus 2 not equal to 0. Done. Okay, but to make not equal to 0, it doesn't mean that the denominator can be negative. No, because the x value, variable value in square root value never be negative. So x minus 2 value should be greater than equal to 0. That means x should be greater than or equal to 2, 2 to infinity. That's it. Khatam. Done. That's it. This is the domain. Next, second question. Determine whether the function is 1, 1. Yeah, they have given f of x equal to x square, x belongs to R. They're asking us to find whether it's 1, 1. What is 1, 1? Every minus 2, minus 3, 0, sorry, minus 1, 1, 2. Okay, this is domain. Let's say from minus infinity to plus infinity, but I'm taking these values. These values should have different mappings, okay, not same mappings. But put the values here. Minus 2, what you will get? 4. Minus 1, you will get 1. 0, what you will get? 0. 1, what you will get? 1. 2, what you will get? 4. See here, minus 2, minus 1, 0, 1, 2. But here, 0, 1, 4. Minus 2 to 4, 1 to minus 1 to 1, 0 to 0. 1 to 1, and 2 to 4. That means minus 1 and 1 are mapping to same element. Minus 2 and 2 are mapping to same element. So this is not 1, 1. Okay? Yeah. Find the inverse of the function. This is also very easy. They have given f of x equal to 3x plus 5. Third one. F of x is equal to 3x plus 5. Inverse. I told just replace f of x with y. This f inverse of y is equal to x. Interchange the values of x and y. Now we will write y is equal to f of x. First step, second step, third step, right? Y is equal to f of x. What is f of x? 3x plus 5. Just make all the terms towards one side except x. Y minus 5, y minus 5 by 3 is equal to x. Okay. Now what you should write? Just interchange them. X minus 5 by 3 is equal to y. Now what is y? F inverse of x is equal to x minus 5 by 3. This is f inverse of x. Okay. First, just write y is equal to f of x. After that, you just make f to other side. F inverse of y is equal to x. This will come here. Okay. And you interchange the variables x and y. Y equal to f of x. Okay. Y equal to f of x. Interchange, like make all the values except x towards one side and write in terms of x, then interchange or put the value of y as f inverse x. Okay, done. So f of x is equal to x plus 1 x. This is g of x. Okay, g of x is equal to x square. Find f of g of x. F of x equal to 2x plus 1. G of x is equal to x square. Okay, they're asking f of g of x. I'll give you homework. You have to find g of f of x. Please do it and submit it in group of Telegram or Educator. Okay. F of g of x. What is g of x? X square. What is f of x? 2x plus 1, but in place of x, x square. 2x square plus 1. Okay. This you have to find on your own. Last question I'm giving this as homework. Kindly do it and come. Okay. Don't think I'll do it during exam. No, you solve it today. Check whether the function is even or odd. I'll give you here just function expansion x greater than 0. If this is x, what will happen? Same value there, right? If x less than 0, if this is x, what will happen? Minus x, right? Okay, this is function. So find whether it's even or neither. That means whether it's even or not, odd or not, or is it not even, not odd. You just find this is homework and do it and come. Thank you so much, and this is enough for your ATC exam. And we have given solutions. If you don't get the answers after trying once or twice or thrice, then look at your solutions and practice more problems on your own. Thank you so much for being here, and thank you. And I'll take this moment to express my gratitude for you for being here. Keep smiling and keep studying. Okay, thank you.